Okay, we're continuing on with Who Am I? I'm on number 8, and number 8 says, I am a transition metal with a very high melting point. Cesium and I are in the same period. All right, so first of all, if you're looking at the periodic table on the screen, the transition metals, remember, are kind of the short columns that are sort of pinkish. Okay, and it says the next thing, cesium and I are in the same period. Here's cesium. So I know that I'm a transition metal somewhere in this row right here. Okay. React violently with water. I'm a soft metal with only one valence electron. If you only have one valence electron, you're going to be talking about something in column 1 over here. Okay. All right, so electrons use more energy levels than lithium, but fewer levels than iodine. Okay. Energy levels in 5, but more energy levels than lithium. So that leaves sodium and potassium as my 2 choices. The last clue, I am not in table salt. Well, table salt technically is sodium chloride. So if you're not in table salt, then that has to leave potassium. Potassium's the only one left. Potassium. Okay, if you flip to the back of the paper, let's go through the back page one by one. Okay, number 10 says fluorine's chemical behavior is most similar to. All right, remember, fluorine's chemical behavior is going to be similar to the other elements in the same column. Okay, so I'm going to look in my answer choices and try to find something that is in the same column with fluorine. Okay. Oxygen's not in the same column, sulfur's not in the same column, and argon is not in the same column, but chlorine is. So your answer for 10 is C, chlorine. Number 11, lithium has the same number of valence electrons as, okay, same number of valence electrons means that it's going to be in the same column, because remember, everything in the same column has the same number of valence electrons and therefore has similar chemical properties. Okay, number 11, lithium has the same number of valence electrons, so I need to look for something in the same column. Okay, beryllium is not in the same column with lithium. Okay, lithium is right here. But hydrogen is. Hydrogen's right on top of it. Okay, so number 11 is going to be B. Number 12, lead, tin, and what are in the same family? Okay, remember that a family is a group or column. Okay. And they are in the same family because they have similar chemical properties. Why do they have similar chemical properties? Because they have the same number of valence electrons. Okay, Pb is lead, Sn is tin, so I'm looking for one of these 3 as my answer choice because it's in the same column, same family. Okay, and the only one that's listed on there as an answer choice is D, carbon. Number 13, neon, nitrogen, and lithium. Okay, lithium is right here. Neon is right here. Nitrogen is right here. Notice that all 3 of them are in the same row. And remember that the period or the row number tells you how many energy levels are being used. So lithium, nitrogen, and neon are all using 2 energy levels. So the answer is A. Number 14, vertical columns on the periodic table are known as families or groups. That's B. Okay, number 15, why are the chemical properties of aluminum more similar to boron than silicon? Okay. Aluminum is right here. Boron is in the same family. It's in the same column. Silicon is next to aluminum in the same row, but remember, it's the ones that are in the same column that share similar characteristics. So why are the chemical properties of aluminum more similar to boron than to silicon? I would write something like, because aluminum and boron are in the same family, meaning they have the same number of valence electrons and similar chemical properties. All right, last one, number 16. If helium has 2 valence electrons, why is it placed in the same family as neon and argon, who each have 8 valence electrons? Okay, so let's look at helium. Helium is right here. Here's neon, argon, krypton, xenon, radon. Okay? All of these in group 18 are called the noble gases. They're a particular type of nonmetal. They are very, very unreactive. They don't really form compounds with anything. And the reason for that is that they all have outer energy levels that are completely filled with electrons. Okay? So helium, even though it only has 2 valence electrons, if you remember, the first energy level can only hold 2, and so helium has a full outer shell of electrons with 2. Okay, you look down underneath that, and it's neon. Neon is using 2 energy levels. So neon has 2 electrons in the first energy level, and neon has 8 electrons in the second energy level. Okay, but the second energy level can only hold 8 electrons, so it's full. And when you have an outer energy level that's full, that element is not reactive. Okay, and the situation is the same for the rest of them. Okay, so they're all unreactive because their outer energy levels are full of electrons already. Okay, so even though helium only has 2 valence electrons, remember that first energy level only holds 2, so helium's outer energy level is full, and it's unreactive for that reason. Okay, that should complete the Who Am I paper for you. So make sure that you have all of the questions answered and the descriptions identified on the front, and then you can put your name on it and turn it in.